Okay, in the last video we analyzed this problem where we were lifting a ball up, which means that gravity was doing negative work, which just means that the ball was transferring energy to gravity in some way. And I told you that if that happens, it's transferring it to potential energy. So whenever a conservative force does negative work, then you gain potential energy. Figured out, well, by lifting the ball up from 0 meters to 10 meters, we've now given the ball this like potential to fall, right? We've kind of powered gravity up in a certain way because it can't do any work when the ball's on the ground. But once we lift it up, now it's got all this distance it can fall. And the more we lift it up, the more it can fall. And we saw at the very end that now that it's lifted up, now gravity can do the longer something has to fall, the faster it will go, right? And if we don't lift it up as high, it won't be able to go as fast. And we see here that if we do the calculation again and figure out the change in potential energy from when it falls from point B to point A now, it's going to be the negative of the work done by gravity, which we have over here. Right, so it's going to be losing 98.1 joules, which means that if it started out at 98.1 joules up here, now it's back down to 0 down here, and that makes sense. And what happened to all of this 98.1 joules that were lost? Well, these 98.1 joules of potential energy that were lost were converted into these 98.1 joules of kinetic energy. Remember, because energy is conserved. So we can't just gain this kinetic energy out of nowhere. It came from this potential energy. Let's do another example. Or try to. Hello, PowerPoint. Here we go. All right, same ball. It's 1 kilogram. And we lift it up, again, we'll say 10 meters. And then we kind of already have the numbers for that, right? So the work done by gravity is equal to negative 98.1 joules. So the change in potential energy is positive 9.81 joules. So now it has 98.1 joules of potential energy up here. And that's us assuming that there's 0 potential energy at the bottom, which is an okay assumption. So now let's say we let the ball drop. But we only let it drop 2 meters. Right, which means that the remaining distance here is 8 meters. So if you let it drop 2 meters, we want to know how fast it's going. Okay, right, so now we can just say, well, the work done by gravity, right, it's the only force acting on it if it's just falling, is going to be the force times the distance. So we'll have 1 kilogram times 9.81 meters per second squared times 2 meters. And that'll give us 19.62 joules, right? So gravity is now doing positive work. So it's transferring this energy. And we know that that's the net work. And the net work is the change in kinetic energy. So it gains 19.62 joules of kinetic energy. And if it were initially at rest at the top, now when the ball's here, we know that it has 19.62 joules of kinetic energy. Where did that kinetic energy come from? Well, it must have come from somewhere. It came from potential energy. Okay, so if we look at the change in potential energy now, remember it's a negative of the work done by gravity, which we found to be 19.62 joules. So that means that it lost 19.62 joules of potential energy. So now it only has 78.48 joules of potential energy. To find the ball's velocity, we just use the kinetic energy equation. V equals 2 times 19.62 joules over 1 kilogram.